Section 7.6, Natural Logarithms. Our objectives for today are to evaluate and simplify natural log expressions and also to solve equations using natural logarithms. The natural logarithmic functions look like these. Notice the one on the left is y equals log base e of x. E and natural log are kind of paired together. The one on the right, y equals ln, which is the symbol for natural log of x. Here, when there's no base, it is an e, where with the log, if there's no base, there's a 10. In problem number 1, simplifying natural logarithmic functions. So what is 2 natural log 15 minus natural log 75? So the first thing we're going to do is try to crush these things together, compress them a little bit. So we're going to take this 2 and it becomes the exponent. So it looks like this: natural log 15 squared minus natural log 75. Now when we're subtracting natural logs, we can write them together. Excuse the song. We can write them together, natural log, and we're going to divide them. So it's 15 squared divided by 75. 15 squared I think is 225. So you have natural log 225 divided by 75, and your answer is 3. So natural log 3. Now on your calculator you should be able to find a natural log key or an ln key. If we were to find out the decimal version, which on this question we don't want to, it would look like this. So if calc is needed, you're going to do 1.0986. Go 4 decimal places there as well. This one stops at natural log 3. Now if you'd like to try the got it questions, you can pause here. What is each expression written in as a single natural log? So with this one, the key symbol is plus. Excuse me. The 2 becomes the exponent, so it's natural log of 7 plus the natural log of 5 squared. Since we're adding them, we're going to multiply the parts. So we get 7 times 25, and the answer is the natural log of 175. All we're trying to do is simplify them a little bit so we don't need to go to decimals on these. For part B, the 3 becomes the exponent here, the 2 becomes the exponent there, and we are subtracting, so that's a key symbol there as well. So it's natural log x cubed minus natural log 2x squared. And notice it's the whole, it's this whole term that gets squared, not just the x. Since we're subtracting, we're going to divide the parts. So we get x cubed over 2x squared. We'll simplify a bit here. So x cubed stays that way. 2x squared would be 4x squared, squaring each term. And to simplify, the x2's would cross out 2 of them and the x cubed on the top, and we just get x over 4. For the third one, the 2 becomes the exponent here, the 3 becomes the exponent there. I think that's the longest song ever. And then we have positives, so we're going to multiply each of these terms together. So it's natural log x cubed y squared times 5. It just looks better when the numbers first, so I'm just going to rearrange them a bit. So 5x cubed y squared. Problem number 2. solving a natural log equation. So what are the solutions here? So the first thing I notice is that there's natural log on one side, not on the other. The base of the natural log is an e, and that's going to get swung to the right. So it looks like x minus 3 squared equals e to the 4. We're going to square root both sides. Remember, when we square root, it becomes plus or minus on the right. If we have 4 e's and we're square rooting, we can take 2 out. And then I'm going to add 3. Okay. If they wanted decimal answers, we could approximate those. If you take 3 plus e squared on your calculator, you get about 10.39. If you do 3 minus e squared on your calculator, you get about negative 4.39. You do need to plug them back in and check to see that they work. So here, when we plug in the 10.4 minus 3 is going to be a positive number, especially when you square it, so you should be okay there. Check to make sure it's about 4, and also put in the negative 4.4 minus 3 when you square it would be a positive number as well. Make sure that it checks out and that you do get 4. And so these do both check. If you want to pause and practice the got it questions, you can pause it now. Here, the base is e. We're going to swing it to the right. X equals e to the 2. Here you can check it on your calculator. E is approximately 7.39. For the next one, natural log on one side, not on the other. E is the base again. It gets swung to the right. So 3x plus 5 squared equals e to the 4. Here we're going to square root both sides like we did on that first question. So we get 3x plus 5 equals plus or minus e squared. I'm going to subtract 5 and divide by 3. Okay, I'm going to write that a little different. So negative 5 plus or minus e squared divided by 3. If you turn those into decimals, you get about 0.8 for one of them and negative 4.13 for the other. You should throw them in there and check them. Again, they are going to be a positive number, so when you check them, just make sure they check out and equal 4, which these do. And the last got it question, we want to compress these together first before we swing the e over. Since it is an addition question, the parts are going to be multiplied, so it's natural log 2x times 3 equals 2. Now I'm going to swing that e over, so I get 6x equals e to the 2. X equals e to the 2 over 6. And that's approximately 1.23. When I throw that in there, I'm going to do the natural log of 2 times 1.23 plus the natural log of 3. When you put that in there, you get about 1.9988, which is pretty darn close to 2. And again, it's not going to be exactly 2 because we rounded on that last step. As long as it's close, it will be fine. Problem number 3, solving exponential equations. What is the solution of 4e to the 2x plus 2 minus 16? So first step, subtract 2. We can divide by 4 since the 4 is not in between. So we get e to the 2x equals 14 divided by 4 would be 7 over 2. Now, when we're looking at this one, we're going to swing the 2x out in front. And since we have an e, we're going to natural log both sides. So this comes down up front, and we're natural logging both sides. So it looks like 2x natural log e equals natural log, and I'm going to put a 3.5. To solve for x, we look at what is the value of natural log of e. Remember, the base is e, and if we're taking the natural log of e, it just cancels itself and you just get 1. So that value is 1. 2x equals the natural log of 3.5, and then divide by 2 at the end. So the natural log of 3.5 divided by 2 is about 1.2528. When you check that, it's going to be 4 times e raised to, I'm going to use parentheses here, 2 times 1.2528, and then you're going to add 2 to it, and you get, oops, I forgot to, okay, I'm going to do this in parts. E raised to the 2 times 1.2528. I'm going to put that 2 times in parentheses there. Okay, I'm going to take it times 4 and add 2. Okay, I just spotted a mistake that I made. 3.5 divided by 2 is 1.2528. You do have to divide that by 2. I didn't. I just did the natural log of 3.5, not the natural log of 3.5 divided by 2, and you get 0.6264. So that answer was incorrect. Now when you plug it in, it does work. You get about 15.99 on the left, is approximately equal to 16 on the right. So that looks good. If you want to pause for the got it questions, go for it, and then check your answers when you're done. Here we have e on one side, nothing on the left. So in order to get rid of it, we are going to natural log both sides, and we're going to move the x minus 2 in the front. So it looks like x minus 2 natural log e equals natural log 12. Remember that natural log of e is 1, so you're just left with x minus 2 excuse me, equals natural log of 12. I'm going to add 2 to both sides and approximate my answer. So about 4.48. If you put that back in, it does check out. E raised to, I'm putting this in parentheses, 4.48 minus 2, which is 11.94, which is approximately 12. For the second one, the 2 is on the outside. So we're going to divide by 2 first. So we get e to the negative x equals 10. I'm going to natural log both sides and bring the negative x in front. So negative x times natural log e equals natural log 10. Remember, natural log of e is 1, so negative x equals the natural log of 10, which is about 2.3 something. So x is approximately equal to negative 2.3. When you check that out, you get 2 times e raised to the negative 2.3, which is positive 2.3, and you get about 19.9, which is pretty close to 20. And the last one, I'm going to subtract 5 from both sides, and you get 10. I'm going to natural log both sides to get rid of that e, and I'm going to bring the 3x out in front. So 3x times natural log of e equals natural log of 10. The natural log of e is 1, so you get 3x equals natural log 10, and then we'll divide by 3. So our final value is the natural log of 10 divided by 3, which is about 0.77. If we plug that in, we get e raised to the 3 times 0.77. I have that in parentheses. I'm going to hit equals and add 5, and I get about 15.07 equals 15, so it does check out. Last question. A spacecraft can attain a stable orbit 300 kilometers above Earth if it reaches a velocity of 7.7 kilometers per second. Its formula is as follows. We need this. And it tells us the values that they want us to plug in. R is 25, C is 2.8, and T is 100. The booster rocket fires for T seconds, so T is the time. The velocity of the exhaust is C kilometers per second. The ratio of the mass of the rocket filled with fuel to its mass without fuel is the R. Suppose the rocket shown, and there is a picture of it on page 480, has a mass ratio of 25, a firing time of 100, and an exhaust velocity of 2.8. Can the spacecraft attain a stable orbit 300 kilometers above Earth? So here, the only thing that we don't really want right now is the 300. We're going to answer that question at the end. So I'm going to substitute my numbers in here. Negative 0.0098. My T is 100, so I'm going to plug that in. My C is 2.8, natural log, and my R is 25. So you can put every single ounce of that on your calculator and you get about 8 kilometers per second, which is greater than that 7.7. So I'm just looking at the velocities that we're comparing. 8 is greater than that velocity of 7.7. So yes, it will reach it will reach the 300 kilometers above Earth. And that is it. And make sure you bring questions with you as you are working tomorrow in class.